Question number 31. A problem in mathematics is given to 3 students whose chances of solving it are 1 by 2, 1 by 3 and 1 by 4 respectively. If the events of their solving the problem are independent, then we need to find the probability that the problem will get solved. So let A be the event where the first student will solve the problem, and the probability that the first student will solve the problem is given as 1 by 2. Similarly, let B be the event that the second student will solve the problem, and probability for the second student that he or she will solve the problem is 1 by 3. And let C be the event where the third student will solve the problem, and the probability of that is given as 1 by 4. Now, one thing is to note that all these 3 events are independent. So now if probability of A is 1 by 2, then probability of A naught will be 1 minus probability of A, and that will be equal to 1 minus 1 by 2, which will be equal to 1 over 2. Similarly, probability of B naught will be 2 by 3, and probability of C naught will be 3 by 4. Just looking at the fraction also, we can calculate the naught part. For example, here probability of B is 1 over 3. So out of 3, the probability that the second student will solve the problem is 1. That means out of 3 times that the second student will not solve the problem is 2, obviously. So that's why probability of B naught is 2 over 3. And similarly, out of 4 times the third student will solve the problem 1 time. That means out of 4 times the third student will not solve the problem is 3 times. That's why probability of C naught is equal to 3 by 4. Now, we need to find the probability that the problem will get solved. So first we will find the probability that the problem is not solved. Okay, so problem is not solved if the first student will not solve the problem, and second student will also not solve the problem, and the third student will also not solve the problem. This is the probability that the problem will not get solved. Okay, so this will be equal to, now since A, B, C are independent, that's why A naught, B naught and C naught are also independent, and using the independent rule we can write this probability as probability of A naught into probability of B naught into probability of C naught. So it will be equal to 1 by 2 into 2 by 3 into 3 by 4. So here 2 gets cancelled, 3 gets cancelled, so it will be equal to 1 by 4. So now this 1 by 4 is the probability that the problem will not get solved. But we need to find the probability that the problem is solved. So therefore, probability that problem is solved will be equal to 1 minus probability that the problem will not get solved. So that means 1 minus 1 by 4 is my answer, which will be equal to 3 by 4. That means correct option for this question is option number D. Question 32. If probability of A is 2 by 3, probability of B is 1 by 2, and probability of A union B is 5 by 6, we need to find the probability of B by A. So this is the question from conditional probability. So now, in order to find this probability of B bar A, so probability of B by A equals to probability of B intersection A by probability of A. So that means first we need to find the value of probability of A intersection B or B intersection A. So now we know probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. So this will be equal to, now probability of A union B is 5 by 6. That's why it is 5 by 6 equals to probability of A is 2 by 3. It's all given in question. Probability of B is 1 by 2 minus probability of A intersection B. That means probability of A intersection B equals to 2 by 3 plus 1 by 2 minus 5 by 6. So it will be equal to, the LCM will be 6, 4 plus 3 minus 5. So it will be equal to 4, 5, 6, 7. So it will be equal to 2 by 6. And that is 1 by 3. So this 1 by 3 is the probability of A intersection B. So we will put this value here. So it will be equal to probability of B intersection A or A intersection B. It's the same thing. So we will write 1 by 3 divided by probability of A is 2 by 3. So here 3 and 3 get cancelled. So my answer is 1 by 2. So the correct option for this question is option number A, that is 1 by 2. Question number 33. Here the probability distribution table is given and we need to find the probability of x greater than or equal to 2. So here we should know that if we add all these values, it is always equal to 1 because the total probability is always equal to 1. So we know probability of P of x equals to 1. So this means we have to add all this, that is 0.1 plus k plus 0.2 plus 2k plus 0.3 plus 3k equals to 1. So here if I add all decimals, it will be 0.6, and if I add all k, then it will be 6k equals to 1. So this implies 6k equals to 1 minus 0.6. This implies 6k equals to 0.4, and this implies k equals to 0.4 by 6. So here it will be equal to 0.2 by 3. So the value of k is 0.2 by 3, but we need to find the value of probability of x greater than or equal to 2. So the value of x greater than or equal to 2 are 2 and 3. That means we have to find the value of 0.3 plus 3k. So here probability of x greater than or equal to 2 means probability of x when x equals to 2 plus probability of x when x equals to 3. So that means probability of x equals to 2 is 0.3 plus probability of x equals to 3 is 3k. And since we know the value of k, then we can write this as 3 into 0.2 by 3. So here 3 and 3 gets cancelled. So it will be 0.3 plus 0.2 and it will be equal to 0.5. Hence my correct option for this question is option number B. Among the examiners in an examination, 25%, 30% and 45% failed in statistics, in mathematics and in at least one of statistics and mathematics respectively. An examine is selected at random. Then we need to find the probability that he has passed the statistics if it is known that he has failed in mathematics. Again, this is the question from conditional probability. So let S be the event where the student has failed in statistics and probability of that is given equals to 25%. See, whenever percentage is given, it's actually the probability, okay? So 25% means 25 by 100. And let M be the event in which a student has failed in mathematics. So the probability of this event is given as 30%. So 30% means 30 by 100. And the question has given this 45% is the probability that the examinee has failed in at least one of statistics and mathematics. So this means the probability of S union M is given, and that is 45%. See, they are saying at least, okay? So that's why I'm using the union sign. If the question had said both in mathematics and statistics, then that time I have to use intersection. So 45% means 45 out of 100. Now, since we know the value of PS, PM and PS union M, we can find the value of P of S intersection M. P of S union M. This is probability of S plus probability of M minus probability of S intersection M. So probability of S union M is 45 out of 100 equals to P of S is 25 by 100 plus 30 by 100 minus P of S intersection M. See, this S intersection M means the student has failed both in maths and statistics. So this implies P of S intersection M equals to 25 by 100 plus 30 by 100 minus 45 by 100. So it will be equal to 25 plus 30 minus 45, and this will be equal to 10 by 100. So the probability that a student has failed in both the subjects is 10 by 100. Now the question is asking to find the probability that he has passed in statistics if it is known that he failed in mathematics. So here's a condition given that he has failed in mathematics. Okay, so that means we have to find the probability that he has passed in statistics. Now since S is the event where a student has failed in statistics, so then we will write S bar. So S bar means the student has passed in statistics. And what is the condition given? Condition is given that he has failed in mathematics. So we have to find the value of P of S naught by M. So here, before using the definition of conditional probability, I can write this probability as 1 minus probability of S by M, because probability of S naught is 1 minus probability of S, and we can just put the condition there. Okay, so this equals to 1 minus. Now we will use the formula for conditional probability, that is probability of S intersection M by probability of M, and it will be equal to 1 minus probability of S intersection M is 10 by 100 divided by probability of M is 30 by 100. Here 100 get cancelled, so it will be equal to 1 minus 10 by 30, that is 1 by 3. So 1 minus 1 by 3 equals to 2 by 3. So this is the probability that a student has passed in statistics knowing that he has failed in mathematics. So my correct option for this question is option number B. Question 35. This is relation R on the set of natural numbers and defined as n is related to m if and only if n is a factor of m. And the assertion is that R is not an equivalence relation, and the reason is given that R is not symmetric. So in this type of questions, we will just check whether the relation is reflexive, symmetric and transitive or not. So at first, let us check whether it's reflexive or not. So now for that, let us assume a natural number n, and we know that n is a factor of n, because any natural number can be a factor of its own. So that means n is related to n, and hence this implies that R is reflexive. So let us check whether it's symmetric or not. For that, let us assume a comma b belongs to the relation R, and if a comma b belongs to R, then a is related to b, and if a is related to b, then a is a factor of b. So if a is a factor of b, then a will divide b, but this does not imply that b divides a. For example, we know that 1 is a factor of 3, but the 3 is not the factor of 1. Hence, it is clear that this relation is not R is not symmetric. Okay, so at last let us check whether this relation is transitive or not. So for that, let us assume A comma B belongs to R and B comma C belongs to R. So if A comma B belongs to R, then A is related to B and B is also related to C. That means A is a factor of B and B is a factor of C. That means if A is a factor of B, then A divides B, and if B is a factor of C, then B divides C. Now this is a simple logic that there's a number A and A divides B, okay, and that B will divide the another number C. So it is clear that obviously that A will divide C. So from here we can write that A will divide C, and if A divides C, then A is related to C, and hence A comma C belongs to the relation R. Hence the relation is transitive. Hence the relation R is transitive. So yes, the relation R is reflexive, the relation R is not symmetric, and relation R is transitive. That means this is not an equivalence relation. Why it is not an equivalence relation? Because R is not symmetric. Now let's read the assertion and reason. It was written that R is not an equivalence relation, which is true, and the reason R is not symmetric, which is also true. And that means assertion and reason both are true, and the reason is the correct explanation for A. Hence my correct option for this question is option number A. Question number 36. The assertion is determinant of adjoint of adjoint of adjoint of A equals to determinant of A to the power n minus 1 whole cube, where n is the order of matrix A. And the reason is determinant of adjoint of A equals to determinant of A to the power n, which is clearly wrong here, because the true statement is adjoint of determinant of adjoint of A equals to determinant of A to the power n minus 1. So here reason is false. Okay, so now let us check whether the assertion A is correct or not. Okay, so for that we need to solve and check the answer. So here on the left hand side of assertion we have determinant of adjoint of adjoint of adjoint of A, and this will be equal to, now see, we will look the definition, that adjoint of any matrix A is equal to determinant of that matrix to the power n minus 1. So here it's adjoint of the matrix of, and the matrix is here adjoint of A. So by looking at the definition we can write this as determinant of adjoint of A to the power n minus 1. Okay, because n is the order of the matrix here. Now again, let us use the definition one more time, that adjoint of any matrix A equals to determinant of that matrix to the power n minus 1. Now this time my matrix is adjoint of A. So here by looking at the definition I can write determinant of adjoint of A to the power n minus 1, and see there was n minus 1 earlier also, so let me write n minus 1 outside. So here it will be adjoint of A whole to the power n minus 1 into n minus 1 is n minus 1 whole square. And for the last time, let us use the definition again here. Simply now we have to find the determinant of adjoint of A. So that means this will be equal to determinant of A to the power n minus 1 whole to the power n minus 1 whole square. So it will be determinant of A to the power n minus 1 into n minus 1 whole square is n minus 1 whole cube. That means my assertion is correct. So assertion is true, but the reason is false, and hence my correct option is option number C. Okay, so now let us read the following passage and answer the questions from 37 to 40. So now there are a set of 4 questions on a single case study. So from question number 37 to question number 40, we have to answer by reading the same paragraph here. So let us read this paragraph. In an office, 3 employees A, B and C process incoming copies of a certain form. A processes 50% of the forms and B process 20% and C the remaining 30% of the forms. Okay, so first let us analyze this part of the question, only this part. Okay, let us consider an event A. A means the event that the form has been processed by A, and the probability of that is given 50%, so it is 50 by 100. And let us consider an event B, which means the event that the form is processed by the person B or the employee B, and the probability of finding out that the form has processed by the second person or B is equal to 20%, and that is 20 by 100. And similarly, let C be the event that the form processed by C, and the probability of C is given as 30%, so that is 30 by 100. Now let us read the second part of the question. A has an error rate of 0.06. Okay, so if the employee A has processed the form, then the chance of making an error by A is 0.06. Similarly, B has an error rate of 0.04 and C has an error rate of 0.03. So this means if the form is processed by A, so this is kind of conditional probability, that if the form is processed by the employee A and the chance of being error. So let me define E as the event that the form is error. So this is given as 0.06, and if the form is processed by B and the error rate of B is given as 0.04, and if the form is processed by employee C and the chance of error from C is given as 0.03. These are the data given by the question. Now let us read the question one by one. So in question number 37, the question is asking to find the probability that B processed the form and committed an error. That means the question has asked us to find the value of probability that the form has been processed by B and error has been committed. So probability of B intersection A. So by multiplication theory of probability, we can write this as probability of B into and probability of E under the condition B has occurred. So this will be equal to, see, probability of B is 20 over 100 and probability of E by B is 0.04. So it will be 20 by 100 into 4 by 100, that is 80 by 10,000. So here 0 and 0 get cancelled. So 8 by 1000 can be written as 0.008. That means correct option for this question is option number C. Okay, this question number 38, and it is a sub question of the same passage. So I have written all the data here also. So now we have to find the total probability of committing an error in processing the form. But this is the question for total probability. So we have to find what will be the total probability of getting an error form. Okay, so now with the formula of total probability, this can be written as, see, the error, to get a form error, the form can be processed by A and A has committed the error, or it can be the form is processed by B and because of B there is an error, or the form has been processed by C and due to C there is an error in the form. Okay, so this will be equal to, see, P of A is given as 50 by 100 into P of E by A is given as 0.06, that can be written as 6 by 100, plus probability of B is 20 over 100, and probability of E by B is given as 0.04, that is 4 by 100, plus probability of C is 30 by 100 into 0.03 is 3 by 100. So let us cancel 1 zeros from here. So here it will be 6 5 is 30 over 1000 plus 8 by 1000 plus 9 by 1000. So it will be equal to 1030 plus 8 plus 9, and that will be equal to 47 by 1000, and this will be equal to 0.047. So the correct option for this question is option number B. Number 39, the manager of the company wants to do a quality check. During inspection, he selects a form at random from the day's output of a processed form. Okay, if the form selected at random has an error, so here the condition is given that the form has been selected randomly and it is found that there is an error, then that time we need to find the probability that the form was not processed by A. Okay, so here we have to find the probability that the form has not been processed by A, that means A not. But what is the condition? Condition is that there is an error in the form. Probability of A naught can be written as 1 minus probability of A under the condition E. So this will be equal to 1 minus probability of A by A. So now in order to find this probability, we use our Bayes theorem. Okay, so first let us use the conditional probability. Then here we will have probability of A intersection E by probability of E, and this will be equal to 1 minus probability of A intersection E. By multiplication theorem, it can be written as probability of A into probability of E under the condition A, and here the probability of E which we have found just now, that is probability of E was 0.047. So it is 0.047. So this will be equal to 1 minus probability of A is 50 over 100 into probability of E by A is 0.06, that is 6 by 100, whole divided by 0.047. We will let us write 47 by 1000. So it will be equal to 1 minus, let me cancel 1 0 here, so it will be 5 6 are 30 by 1000 by 47 by 1000. 1000 get cancelled, so it will be 1 minus 30 by 47, and this will be equal to 47 minus 30 by 47, that will be equal to 17 by 47. That means my correct option is option number A. The last question of this model set. If E be the event committing an error in processing the form, and let E1, E2 and E3 be the events that A, B and C process the form, then we need to find the value of this expression. Okay, so now here as you see, we have already supposed the event A, B and C, but here in question they have written E1, E2 and E3. So note that this E1 is the event A, and E2 is the event B, and E3 is the event C. So now we need to find the value of summation of I equals to 1 to 3 probability of EI under the condition E. So let us open the sum. Then this means probability of E1 under the condition E plus probability of E2 under the condition E plus probability of E3 under the condition E. So this is actually E1 is my event A only. This is event B, and the event E3 is my event C. Okay, so now let us use the conditional probability. Then we will have P of A intersection E by probability of E plus probability of B intersection E by probability of E plus probability of C intersection E divided by probability of E. Since the denominator is same, so let us take the LCM, and in numerator let us use the multiplication theorem. So probability of A intersection E is probability of A into probability of E by A plus probability of B intersection E is probability of B times probability of E by B plus probability of C intersection E is probability of C into probability of E under the condition C, whole divided by probability of E. In numerator, as you see here, this is the total probability of making an error, because error can be made by A. See, the form has been processed by A and A has committed the error, or the form has processed by B and B has committed the error, and the form is processed by C and C has committed the error. So this numerator is actually the total probability for committing an error. That means my numerator is probability of making an error divided by probability of E. So since my numerator and denominator are same, so my final answer would be 1. So the correct option for this question was option D. So this is the end of this model question. I hope you got to learn something new. So all the very best for your upcoming semester 3rd examination, and thank you.